Hello everyone. Today we are going to do section 2.5, solving other type of equations algebraically. So the topics we are going to be covering today are solving polynomial equations of degree 3 or greater, and then we'll solve equations involving radicals and equations involving fractions or absolute values. In this video, I'll be focusing on solving polynomial equations of degree 3 or greater. Let's start with an example. So we're going to solve this fourth degree order polynomial equation. 9x4 minus 27x squared equals 0. The highest power of the polynomial is a 4 here. So let's start this one. Let's write this equation. And now look at this equation on the left hand side. 9x4 minus 27x squared. We'll try to take the common parts out. And when look at the common, 9 is common between 9 and 27, so 9 comes out. Between the variables x to the power 4 and x to the square, x squared is common. So 9x squared is taken out, and inside the parentheses you have x squared minus 3. We can apply the zero factor property to solve this problem. We have 9x squared equals 0 or x squared equals 3. Basically, x squared minus 3 equals 0, or that means x squared is 3. So when you focus on the part 9x squared equal to 0, this is always true when x is 0. On the other hand, when x squared minus 3 is equal to 0, that means x squared is 3, or x is plus minus square root 3. So the solution to this problem of polynomial of degree 4 is x is 0, which is repeated twice, and x is plus minus square root of 3. So let's go forward and look at this example. Now this is a cubic equation given by 6x cubed minus 24x squared minus 54x equal to 0. So when we solve this cubic equation, we have to see what are the common factors. Clearly notice x is present in each of these terms in this left-hand side of this equation. And also there's something common between the constant terms, your 6, 24, 54. 6 is a common factor here too. So we take 6 and x out, and inside the parentheses we are left with x squared minus 4x minus 9. Once again, we apply the zero factor property. Zero factor property says either 6x is 0 or this whole expression of the quadratic is 0. So that means x squared minus 4x minus 9 is 0. So when we do this 6x equal to 0, automatically x is 0. But to find what x satisfies this quadratic function here, x squared minus 4x minus 9 equal to be 0, we can go and apply the things we have learned earlier. To solve this quadratic equation, remember we can apply completing the square or use a quadratic formula, or if we can make factors. So let's write this one down. We have x squared minus 4x minus 9 equals 0. Now, if you think back, we cannot easily write it into simple factors because 9 has, common, like what are the factors for 9? You have 3 and 3, 9 and 1. There is no way you can get a 4. So the best option is apply the quadratic formula or completing the square. So I'm going to apply the quadratic formula here. Now remember the quadratic formula. If you're given ax squared plus bx plus c equals 0, the quadratic formula is given by minus b plus minus square root b squared minus 4ac over 2a. So let's look at what are the a, b's, and c's present in our quadratic equation. Our a is 1, b is minus 4, and c is negative 9. Now plugging these values in this formula, we get x equals minus of minus 4 plus minus square root b square is what? Minus 4 square minus 4a is what? 1, c is negative 9 divided by 2 times 1. What do we get here? 4 plus minus square root, minus 4 square is what? 16 plus 36 divided by 2. This is equal to 4 plus minus square root 52 divided by 2. Now we can actually find factors of 52 and see something as a proper square here. So let's go ahead, and I'm going to take a little space here to show the work. I'm going to take a different color too. Okay, now let's look at this one. Square root 52. Now 52, guys, can be written as 13 times 4. Now 4 carries square root of 4. We know this can be written as square root 13 and square root 4. So we have 2 square root 13. So we come back to this equation. We have 4 plus minus 2 square root 13 over 2. Notice this 2 is common in all the 3 terms here. So we can write 2 out. 2 plus minus square root 13 divided by 2. Clearly, we can cancel the 2 here, and we are left with 2 plus minus square root 13. So the solution to x squared minus 4x minus 9 equals 0 is given by x equals 2 plus minus square root of 13. And let's go back and write it in the original problem. So for x squared minus 9, this is x equals 2 plus minus square root 13. So the solution to this problem is either x is 0 or 2 plus minus square root 13. Now let's look at another problem. Again, it's a cubic problem, and this one is 2x cubed minus 6x squared plus 6x minus 18 equals 0. So when you look at this one, we have the variable x in only 3 terms, not over here. So in order to solve this one, we can use an idea by grouping the first 2 terms and the last 2 terms. That's what I've done over here. So when you look at the first 2 terms, 2x squared is common. And when I take the 2x squared out, I'm left with x minus 3. And when I group the last 2 terms, 6 is common. And I take the 6 out, and I get x minus 3. So in this equation, guys, x minus 3 is common. So we can factor the x minus 3 out from these 2 expressions. And we get x minus 3 times 2x squared plus 6 equals 0. Once again, we have an expression on the left-hand side which is a product of 2 terms, and we can apply the zero factor property. That means 2x squared plus 6 equal to 0, or x minus 3 equals 0. Now this one is very easy. X is simply 3. Let's look at 2x squared plus 6 equals 0. So when we have 2x squared plus 6 equals 0, 2x squared is minus 6. x squared is minus 3. Now, in order to get the values for x, when you take the square away from the left-hand side, we basically get plus minus square root minus 3. We have learned about complex numbers, guys. And complex number says if you have a negative present, you can remove the negative by writing an I in the front. So it's plus minus I square root of 3. So the answer to this cubic problem is plus minus I square root of 3, or x equals 3. Let's look at one more example in the solving of polynomials of degree 3 or higher. Now, this is a polynomial here which is of degree 4. x4 minus 5x squared minus 6 equals 0. Now, when we look at this one, it's not that easy to solve. But if we do some substitution and make it to a simpler kind of a problem, we are all comfortable, like the quadratics. Notice this x to the power 4 is nothing but x squared square. So if I say let x squared be u, then what happens to x to the power 4? It becomes u squared. So when we substitute this u squared and u in the original problem, what do we get? The new equation becomes u squared minus 5u minus 6 equal to 0. So the polynomial which was given of degree 4 here has now become a quadratic. Now easily we can solve quadratic, and once we can solve quadratic, we can go back to the original problem and solve it for x, because that's where the real question was. At this time, let's go back to the quadratic we did by substitution. We got u squared minus 5u minus 6 equals 0. So clearly we can easily make factors. Minus 6 has factors minus 6 and 1, and which easily works because we can get a minus 5. You can write this as u minus 6 and u plus 1 equals 0. Once again, applying the zero factor property, we get u minus 6 is 0 or u plus 1 is 0. We get u to be 6 or u to be minus 1. Now remember, the original problem was in variable x. So we have to go back there. So when u was 6, that means x squared is 6. Remember, this is the substitution we're talking about. When x squared is 6, so let's come back here. So when my x squared is 6, that means x is what? Plus minus square root 6. We are done here. Now when your x squared is minus 1. Now x squared is minus 1. X equals what? Plus minus square root minus 1. Now you remember, minus 1, square root of minus 1 from complex numbers is nothing but a I. It is plus minus I. So the solution to this problem is x equals plus minus square root 6 and x equals plus minus I. Thank you, and I'll see you later when we solve radical roots and absolute value problems.